So, bit of a chunky setup that we've got going here. What the bad Jesus. Woo! Got 4 LEDs, neons lit up here. So let me run you through. Can you figure that one out? We've got blue going to... That's actually green. Wow. That's actually green. Those are also green. And that's green. Wow. Alright. Call it pale blue then. This is a proper Tesla bifilar pancake coil. As in, it's made out of 10mm copper tape, separated by a layer of regular old poly tape. 2 layers wound. The grey outer goes to the blue inner. The green, they were suspect about the green, though in real life it's obviously very green. The green is to the purple. So, here we've got across grey, outer turn to blue. So we've got the outer turn, inner turn, then we've got an inner turn and an outer turn. If that makes sense. And when we look at the diagram, there we go, we've got this. We have grey and green, 2 outer turns, blue and purple, 2 inner turns. They're capacitively coupled with a parasitic capacitance because of the way they're wound. There is a neon across each coil. There is a neon crossing antiphase, and they light up. It's a bit tricky because I'm holding my camera. I don't know where my tripod or anything is. Well, this is my driver here. This is just an auto relay running at 45.7 volts. It's been running it quite a while. As you can see, it's drawing barely any power. Just watch here. This is this little buzzer here. La 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 la. And if I push on it, I can make the frequency go up. I have 430 nanofarad, 0.1, so 100 microfarad, and the other ones are 0.33. These are high frequency induction heater pulse rated capacitors. So back on this thing, what was I saying? Yeah, this is my beeper. I can change the frequency, and as you can see, when I push on it fairly hard, my neons get quite bright. This one here in particular tries to blow up. You don't get it on the camera, but it's got a really nice arc going on in there that you're not seeing. And my current goes up to still sweet F4. Oh, a few watts. Yep. Yeah. So anyway, there's a few strange anomalies. Good job. The circuit itself is actually Tesla's actual way of wiring them up. This is just the number. You need to get a normally connected. It's got to be a 5-terminal auto relay. As you notice here, it's the ones with the extra one, the 87A pin. So you're shorting one side of the coil to the normally closed. Power comes in on the one side of the coil, has nothing attached, so it just goes through the relay, powers it up. The contacts to the common is the other power source and the 2 capacitors, which then goes over these wires to a primary turn, which is 4 turns of ribbon conductor that are just stuck on there. It's a little experiment with no idea. There's no tuning on this, there's nothing. Like, come on, it's janky as I just whipped it together just to see my lights light up, of course. I've got approximately 128 turns on each layer there. I didn't count anything, I just shoved it together. It measures to be 175 nanofarad at 840 microhenry per turn. But it's really weird when I try and get readings, it goes all over the shop. I'm getting a reading like 190 millihenry in series. Obviously I can't measure my capacitance when they're actually wired up in series. That is, I short the blue to the green, or I short the purple to the grey. I wound it that way so that I could just easily shunt that. What then happens though is, I'll demonstrate that in a second. It's not sort of what you expect. So at the moment, as I say, I'm wired up in this configuration. If I put a neon across here, it won't light. If I put a neon across here, it won't light. If I wire these up in series so that my blue goes to green and I put my neon across from purple to grey, it doesn't light up. If I do it the other way around, so I'm putting grey to the purple and I put my neon across green to blue, it doesn't light up. But the very interesting thing is that if I put a neon across the grey and green and the blue and purple, the blue and purple are towards the inside of the coil. They will light up if I touch the neon. I'll demonstrate that one, because that's not too hard. Let me see. Excuse me if I lose your wrong screw. Like, what am I doing here? Alright, so dish. Neon's going everywhere. So now I wanted to short my blue to purple. So this is my 2 inner turns. Excuse me. This is awkward. I need 15 hands. Blue to purple. So this is the inner turns. And I go. So what you see there is nothing. And I'll just push on my little relay here and make it go. There's a tiny bit if I really push it hard. And that's the same. Do you still see anything? If I touch it, it lights up. So that's the 2 inner turns. And that's without a neon shorting the other side. Now if I go at the same time, where'd my screwdriver go? So if I then touch this one, so that line up there is just shorting out there, but anyway, dash. So this one goes across the 2 outer turns. You can see it's not lighting up. Now, this makes sense because these should be at the same potential because they're 2 coils in parallel. So, as you can see, nothing happening there. That one's shorting green to grey, and that one's shorting. But if I touch this one, I don't know if you see that there, you get just a little bit of light if I touch that one. There's that one, no such thing happens. So this is the 2 outer turns, and there's nothing here. The 2 inner turns, there is. Now that's just a capacitive coupling to who knows what, to this. It doesn't seem to matter if I touch this coil or not. Now what was my last demonstration going to be? I was going to join, say, my blue to the green. I like to join grey to purple. opposite of how I wired it up. And I see those two, that they were close together, so I could just put a solder shunt across. So what I was about to do, put grey to purple, with a shunt. So I was going to put a neon across blue to green. Yeah. Okay. So this, as expected, but notice that the other two are not. You know, I can join this and it doesn't matter. Where am I? Remember, these neons are basically an open circuit until they conduct at roughly 90 volts, 70, 90, whatever the strike voltage is, and then they basically become a conductor, a fairly low resistance. So anyway, here's my shunting wire, nice and simple. I'm just going to shunt, what did I say, purple and grey? So that should be the, you know, that should cause blue and green to be at the end of two coils in series. Everything goes out. Now, if I short, that was grey to purple, blue to green, that means that purple and grey should be at the ends of the two coils, which, as we demonstrate here, are opposite potentials. So then we short them and we short it out nicely, everything goes out. I don't know if you can see that, but just where I'm scraping that wire on the terminals, there's a little arc being formed. Anyway, so as you can see, when I put them in series, suddenly I've got no potential across here again. I'm not sure what's going on there. So yeah, that was, again, by wiring blue to green and having a neon, so this neon goes out. The one from purple to green goes out if I short blue to green. If I short grey purple, the neon between blue and green, and these two will go out as well. Who knows? So yeah, it does show some peculiar characteristics, but anyway, this is Tesla's actual coil. Let me just give a second here. Got to open the computer. Yeah. If I had fancy editing software, you know, this is how you get it. Power comes in at the end of the coil, up through the quick switch. So the coil end goes to the primary of your Tesla coil, the terminal of condenser. Your other condenser comes from the power supply dunk. So basically, that's what it is there, that the condenser comes from the contact dish. The coil is coming from the connection of the switch, so as soon as this relay pulls down, it opens. You get a high voltage pulse which charges the capacitor. When this closes again, you get a ringing in here, which is completely separate to the current flowing through here. You have a DC current through here charging this, and this is biased off, because this isn't really relative to, and this produces that. And anyway, the actual, once again, real coil, now that is one of these oscillators. This is Tesla's electrical oscillator, and I've never seen anybody demonstrate anything quite like one of these. So forget your turbines, forget your AC motors. I've seen these sitting in museums and people just walk straight past them and ignore them. These things are huge. They don't realise that here is a real Tesla coil that is capable of showing phenomena like this. and they just sit there in a museum ignored. Yeah. I really don't subscribe to the fanboy club. Sometimes it just really pisses me off.